Welcome to this explainer. If you've been scrolling through the news lately, you've probably been hit by a total barrage of sensationalist headlines about the geopolitics of tech. Claims that one country has entirely eclipsed another, or that certain regions are just completely losing their edge. Well, today we are going to cut right through all that noise. We're going to look at the hard, cross sector data straight from the Belfer Center and the Australian Strategic Policy Institute to reveal what is actually happening in the global race for technological supremacy. All right, let's just dive right in with a number that honestly stopped me in my tracks. 37. Out of 44 critical technologies tracked by the Australian Strategic Policy Institute, China is currently leading in 37 of them. We're talking defense, space, robotics, energy, advanced materials. It's a staggering figure that really puts the sheer scale of this global competition into perspective. But, as we'll see today, leading in research doesn't always automatically equate to total global dominance. Now, the actual reports behind this data are, frankly, incredibly dense. But don't worry, we're going to unravel all this complexity with a really clear six-part roadmap. We'll look at the race for future power, the US-China duopoly, hardware choke points, frontier tech, the global war for talent, and finally, how nations can actually survive this race. So, let's hit section 1, the race for future power. Tech is the new currency. Listen, technology is no longer just about the newest smartphone in your pocket or how fast you can stream a movie. It is literally the currency of modern geopolitical power. The Belfer Center defines this technological power as a nation's ability to achieve its goals by controlling resources, materials, and ideas in an era of innovation. The most powerful nations out there aren't just buying tech off the shelf. They are building massive, advanced innovation ecosystems. They're pouring funds into research, pulling the brightest minds, and using these advancements to catalyze change on the global stage. In our highly interdependent world, technological power basically equals sovereignty. Moving right along to Section 2, the US-China tech duopoly, the global scoreboard. Take a look at this Belfer Index scoreboard. We're tracking AI, biotech, semiconductors, space, and quantum here. And wow, a stark reality really jumps right out at you. The United States currently leads the pack with a total score of 84.3. But China, they are closing that gap fast, sitting right behind at 65.6. And Europe, well, even when combined as a whole unified bloc, they're acting as a highly competitive third wheel, down at 41.0. Honestly, no other single nation even comes close to those top two. For all intents and purposes, we are looking at a massive US-China duopoly. But here's where it gets fascinating. The way these two giants actually succeed, completely different playbooks. The US innovation ecosystem is highly decentralized. It's fueled by private capital, venture funding, and this wildly diverse research workforce spread out across universities and startups. China, on the flip side, relies heavily on centralized planning. They excel at state-backed manufacturing, massive public investments, and leveraging their absolute sheer scale to reduce import dependence and force domestic innovation. Totally different strategies, right? But both are yielding some really massive technological dividends. Which brings us to Section 3, choke points, semiconductors, and space. This is where the hardware really dictates the winners. When we get down to the physical realm, the actual hardware, immense capital and legacy infrastructure create major vulnerabilities. Take the advanced semiconductor supply chain. These tiny chips run absolutely everything in our modern lives. But look at how crazy fragmented the creation process is. The US completely dominates chip design and the software tools needed to map them out. Taiwan dominates the specialized materials and wafers. When it comes to the actual fabrication and manufacturing of the chips, it's Taiwan and South Korea leading the pack. And finally, for assembly and testing, China holds the dominance there. All of that leads us right to this absolutely crucial quote from the report. No country has complete end-to-end control of a supply chain for advanced semiconductors. It's like a giant global puzzle. Because of this profound interdependence, even if you have unlimited capital, you just cannot buy your way into making everything from scratch overnight. The technical barriers and the legacy infrastructure are just way too immense. To really put this vulnerability into perspective, get a load of this number, 70 to 90%. That is the percentage of the world's most advanced transistors manufactured by just one single entity, the Taiwan Semiconductor Manufacturing Company. I mean, imagine for a second if 90% of the world's coffee came from exactly one farm. The global caffeine withdrawals alone would dictate foreign policy overnight, right? Well, this is the digital equivalent of that. It's a massive bottleneck, and it perfectly explains why semiconductors are at the absolute center of modern geostrategic planning. And then there's the other major hardware choke point, space. Now, the US holds a really strong lead here, mostly thanks to incredibly productive public-private partnerships. Think about SpaceX bringing launch costs way, way down. But the data highlights a huge strategic risk, asymmetric vulnerability. Because the US is so deeply, fundamentally wired into space-based systems for both its economy and its military, any rising anti-satellite capabilities from competitors create these huge, glaring blind spots right up there in orbit. All right, Section 4, Frontiers, AI, Biotech, and Quantum, the Convergence Zone. The tension in these rapidly converging fields is palpable. ASPE tracks what they call technology monopoly risk. And if you look right at those top rows, the ones in red, in areas like advanced radio frequency communications, which covers 5G and 6G, China has an overwhelming lead. They're capturing nearly 30% of the high-impact research, compared to just 9.5% for the US. That translates to a very high risk of a single-nation monopoly on foundational future tech. And when we zoom in on the AI race specifically, we see two totally different power bases clashing. The US is holding on to dominance through unmatched economic resources, incredibly advanced algorithms, and just raw computing power. But China? They are mounting an intense catch-up effort. They're leveraging a massive amount of raw human capital, insane volumes of domestic data, and really clever, cost-optimized lean models like the DeepSeek architectures that actually train effectively using far fewer computational resources. So the US lead is definitely there, but man, it is entirely vulnerable. Now, you might be sitting there thinking, okay, this is strictly a game for the massive superpowers, right? Well, check out this number, 5%. Canada currently harbors 5% of all global quantum talent. They've authored over 1,000 research papers on it recently. Why is that wild? Because Canada has only 0.5% of the global population. It just goes to show that with laser-focused strategy and strong national funding, smaller nations absolutely can carve out incredibly powerful, durable niches in frontier tech. Let's move to Section 5, the global war for talent, brain drain, and brain gain. Because ultimately, beyond all the chips in the code, this is a war for human brains. If you follow the flow of machine learning talent here, you'll see a massive pool originating at the undergrad level in places like China and India. Fast forward to the postgraduate level, and the US acts like a giant magnet, pulling in a huge influx of that international talent. But here is the critical vulnerability. At the actual employment level, the US experiences a serious brain drain. They're losing a huge chunk of those highly trained experts right back to China, South Korea, and the UK. If a country wants to maintain long-term tech supremacy, they have got to figure out how to plug that leak. Finally, Section 6, Surviving the Tech Race, Alliances and Interdependence. So how do countries actually survive this incredibly high-stakes competition? Well, the reports lay out a few very clear strategies. First up, reshoring and friendshoring critical supply chains, basically making absolutely sure you can get what you need during a global crisis. Second, implementing targeted export controls to essentially pump the brakes on competitors at key bottlenecks. Third, and this is probably the biggest takeaway, deepening collaborative partnerships. The data proves the US is just so much stronger when aligned with allies like Europe, Japan, and South Korea. And finally, for mid-tier countries, survival is all about finding that niche vertical specialization, like Canada with quantum, so they become an absolutely indispensable part of the global machine. Because look, as AI accelerates biotech and quantum computing completely reshapes materials science, the gap between the leaders and the laggards is just going to explode. In this era of rapid technological convergence, relying completely on foreign ecosystems, that's a massive strategic risk. So considering all the data, the massive investments, and the talent pipelines we've just walked through today, will your nation be a maker of its technological future or simply a taker? It's a lot to think about. Thanks so much for joining me for this explainer. And as always, keep questioning the world around you.